Mathematics, paper 32, mechanics. Friday, 14 June 2019. Answer all questions and ensure that all your answers to parts of questions are clearly labeled. You should show sufficient working to make your methods clear. Answers without working may not gain full marks. The total mark for this part of the examination is 50. Paper 32, mechanics. In this question, position vectors are given relative to fixed origin O. At time t seconds where t is greater than or equal to 0, a particle p moves so that its velocity v meters per second is given by that. Find the acceleration of p when t is equals to 4. So we're going to be using some of these formulae down here. So it's very important for you to look at. Like, for example, acceleration is dv over dt. Velocity is displacement of ds over dt. So displacement is integral of v dt. So look at this formula. We're going to be using some of them. So to find the acceleration, we've been given the velocity, and acceleration is dv over dt. So acceleration, to get acceleration, we differentiate the velocity. So we differentiate the velocity to get the acceleration. So when you differentiate 6ti with respect to t, you get 6. And when you differentiate 5t to the power 3 over 2, 3 over 2 comes to the front, so you multiply by 3 over 2 and subtract 1 from the power. So 3 over 2 minus 1, it gives you a half. And 3 over 2 times 5, it gives you 15 over 2. So that's your acceleration. But we want the acceleration when t is equals to 4. So we take that 4 and substitute it in there for t. And when you put that in your calculator, you have 6i minus 15j meters per second. And that is the acceleration at time t equals to 4 seconds. For part B, find the position vector of P when t is equals to 4. So we get the velocity. To find the displacement is integral of v dt. We're using that formula there. So that means we want to integrate v with respect to t. And when you integrate, you add 1 to the power. So t to the power 1. So 1 plus 1, which will give you 2. Divide by 2, the new power. And then we'll add 1 to 3 over 2 and divide by 3 over 2 plus 1. So when you integrate that, you get 3t squared I minus 2t to the 5 over 2j plus c. C is a constant of integration. But it tells us that t is 0. The position vector of P is minus 20i plus 20j. So you can substitute that in, but you know what the constant of integration C is, minus 20i plus 20j, which we can verify with that. So that's what S is. And that is that your C there, which represent the C. Now we want to put t is equals to 4 because it tells us when t is equals to 4. So we substitute 4 for t there, substitute 4 there, and substitute. Okay, that's it. And that will give us 3 times 4 squared, 2 times 4 to the power 5 over 2. Now we put all the i's together. 48i minus 20i will give you 28i. 64j plus 20 minus 64j plus 20j gives you minus 44j. So that's what you get for S. Question number 2. A particle P moves with constant acceleration, 2i minus 3j. Okay, and it wants us for part A, find the value of t. We're going to use the Shewhart equations, and these are the Shewhart equation 1, 2, 3, 4, 5. It's given in the formula book, so you can just get it from there. We want to find the value of t. So we use V is equals to U plus AT. And U is minus I plus 4j from the question. And A is 2I minus 3j. We sub that in, we put in U, put in A, and then we put the i's together. So be 2t minus 1 all I, and then 4 minus 3t all j. So that's what your velocity would be. So at time t is equals to 6 seconds, p is moving in a direction of 3I minus 4j. So t is equals to t, and v equals to some constant times 3I minus 4j. So when the ratio of I is to j, or 3 is to minus 4, so you go minus 4 times 2t minus 1 is equals to 3 times bracket 4 minus 3t. And we solve it for t. Minus 9 comes to this side. Minus 8t plus 9t will give you t, and 4 goes to the other side. 12 minus 4, it gives you 8. So t is equals to 8 seconds. So that's question 2A written down neatly. For question 2B, at time t equals to 4 seconds, P is at point B. Find the distance AB. So we're going to use this. S equals to ut plus half at squared. And u is minus I plus 4j, and a is 2I minus 3j. So we substitute u and we substitute a. And t is 4. So we substitute t for is 4 as well. So that will give us t there for 4 and t there for 4. So go minus I plus 4j times 4. And we remove the bracket. That will be 4 times minus I minus 4I. 4 times 4j, 16j. 4 squared is 16. 16 times 2 is 32. 32 divided by 2 is 16I. And this one will give us 24 minus 24j. So we put the i's together. Minus 4I plus 16I, it gives you 12I. And 16 minus 24j is minus 8j. So we want to find the magnitude. So it's 12 squared plus minus 8 squared. It gives you 14.4 meters for AB. So that's question 2B written neatly. Question number 3. Two blocks A and B of masses 2m and 3m respectively are attached to the ends of a light string. Initially, A is held at rest on a fixed rough plane. And it wants you to show that T is equals to 12 mg over 5. One of the most important things is to get your diagram correct. So what we have here is we have the mass of 2m. The weight is acting downwards. So the weight is 2 mg acting downwards. And we got another mass here, 3 mg at B acting downwards. So the mass acting downwards, the force is acting downwards, that gives the weight, and there's also a tension going upwards. So there's upward force there and there's downward force there. Now the reaction is at 90 degrees to this plane. So this angle there is 90 degrees. So that's the reaction force. So this reaction force, if you get the opposite coming straight down, that is 2 mg cos theta. You use cosine is adjacent over hypotenuse. Cos theta is adjacent over hypotenuse. But it's not theta, it's alpha. So you call cos alpha is adjacent over hypotenuse. So this one is 2 mg cos alpha because the hypotenuse is 2 mg. Now, if you're going down this way, that's the opposite to that alpha. So you use sine. Sine alpha is opposite over hypotenuse. So this one here is 2 mg sine alpha. Sine alpha is opposite over hypotenuse, which is 2 mg. So that means 2 mg sine alpha. And you can put it up there, which is the same. This and this are the same. That's showing that the force pulling it down the inclined plane is 2 mg sine alpha. And the one pulling it up is T. We'll call it T, the tension from the string. And then there's friction, because friction will stop motion. Tension is pulling it to go up. Friction is opposite, pulling it down. Friction is in this pink. See the pink color there, that's friction. Friction is F equals to mu R. So remember that friction F equals to mu R. You remember that formula. So acceleration is the particle is going up and down this way. That's the motion. It's going down like this. So this one is pulling down. Tension is pulling up. This tension here is pulling this particle up this way. And then there's the weight component of the weight coming down. And there's friction coming down. And that's the component of the weight right angle. Very important to get this diagram right. Draw a large diagram, and once you get it right, you can start to solve things on it easily. Normal reaction between A and the plane. R is equals to 2 mg cos alpha. That means upward force is equals to downward force. Remember that. Upward force is R, downward force is 2 mg. And because the normal reaction is R and they stay the same, they are equal because it's not going up and it's not going down. It stays where it is. So upward force is equal to downward force. That's what you remember. So R is equals to 2 mg cos alpha. Now, cos alpha, how do we find cos alpha? We go into a right angle triangle. We have sine alpha is 5 over 13. So use the triangle 5, 12, 13. Because tan alpha is 5 over 12. Tangent is opposite over adjacent. So that's 5 for opposite, and then adjacent is 12. And then you use Pythagoras theorem. 12 squared plus 5 squared square root will give you this to be 13. So sine alpha is opposite over hypotenuse, which is 5 over 13. Cos alpha is adjacent over hypotenuse, which is 12 over 13. Now we replace cos alpha, 12 over 13. So 2 mg times 12 over 13. 2 times 12 is 24 over 13. Next thing we have is force of friction is F equals to mu R. That's the force, the friction there. I've put it in pink and is pulling opposite direction to movement. And they say the coefficient of friction between A and the plane is 2 over 3. That coefficient of friction 2 over 3 is given. So that means maximum force for friction is 2 over 3 times R. Do we know what R is? Yes, we just done R from above. So it's 2 over 3 times 24 mg over 13. So that gives you 16 over 13 mg. Now we want to consider particle A only and write the equation of motion for particle A. Just A only. So what is the forward force is T. So the way you do it is the forward force minus backward force is equals to MA. So we are using F equals to MA. Forward force minus backward force gives you the resultant force, and that's equals to the mass times acceleration. The forward force is T. T is the one pulling it forward, the tension. What is the backward force? The backward force is the friction force plus the component of the weight pulling it. So there's one pulling it up forward and two pulling it backwards. You see that? Forward force is the tension pulling it up, And then backwards is the one pulling it back due to the weight and the one pulling it back due to the friction. So we subtract the two backward force. So the force backwards due to friction minus the force backward due to the weight is equal to the mass times acceleration. Next, we consider equation of motion for B, for the 3m for B, the equation of motion. There's two things, pulling up and pulling down. So we would say upward force and downward force. So which way is it moving? It's moving downwards. So the downward force is bigger. So we would say downward force minus upward force is equals to MA. The downward force is 3 mg minus the upward force is T is equals to the mass 3m times acceleration because it's moving down. So now we have two equations, equation 1 and equation 2. We want to solve it for T. To solve it for T, we can add equation 1 and equation 2 to find, so that T would eliminate, and then we can find acceleration, and then after that we can find T. So for equation 2, we can swap it. The minus T can come to the left, so it becomes minus T plus 3 mg. All we have done is swap their position. 3 mg comes there and minus T comes to the other side. And the reason is because when we write down equation 1 like this, we can put the minus T to match. So we add equation 1 and 2. T plus minus T, it gives you 0. And then we have plus 3 mg, plus 0 is 3 mg, minus F, frictional force maximum, minus 2 mg sine alpha, and then 2 ma plus 3 ma, it gives you 5 ma. So this is what we have now to solve. Now we see there's m on each one. So we want to get all the m's out. We replace F max. F max was 16 mg over 13. So we replace F max first, the frictional force. Now we cross out the m's from all of them. The frictional force is that. What we have now, because we got F max, that's F max. So what we have now, we have 3g minus 16 over 13g minus 10g over 13 equals to 5a. We want to solve it for a. So all of this, 3 minus 16 over 13 minus 10 over 13 will give you 1g. So 1g equals to 5a. A would be 5g divided by 5. Now you know what a is. You would take a and substitute it for a in that formula there. So we got, make t the subject first. So t is equals to 3 mg minus 3 ma. So we can take t to the right, it becomes plus t, and take 3 ma to the left, it becomes minus 3 ma. So we make t the subject. But we know a is g over 5. We'll put that in there. So it's 3 mg minus 3 over 5 mg. That gives you 12 over 5 mg. So you have shown that t is equals to 12 mg over 5. QED, quod erat demonstratum. After B reaches the ground, A continues to move up the plane until it comes to rest before reaching P. Determine whether A will remain at rest. Carefully justify your answer. So what we want to do is, what are the forces that are pulling A? If you look right down at the bottom left, that's the thing A which is on the ram there. I'm just shading it red. What is pulling it downwards? The force of due to the gravity, the gravitational force from the weight is 2 mg sine alpha. What is pulling it up? is the frictional force is to do with frictional 2 over 3 times 2 mg sine alpha frictional force, because the weight is trying to pull it to slide down. Friction is stopping it from sliding down. So friction is now acting upwards. Now we want to compare downward force and upward force. Which one is bigger? So the downward force 2 mg sine alpha and 2 over 3 times 2 mg for frictional force. So what happens is you have 16 mg over 13 is bigger than 10 mg over 13. So thus A will not move. The forces acting on A are gravity and friction. And 2 mg sine alpha, 2 mg times 5 over 13, because that's what sine alpha is. That gives you the 10 mg over 13. So the frictional force is bigger than the gravitational force. Therefore, block A will stay at rest. So it wouldn't slide down because the upward force is bigger. So it will hold it to stay there at rest. It will not move. Part C, suggest 2 refinements to the model that would make it more realistic. Normally, there's air resistance. So we have the model to consider air resistance. The friction of the pulley, there's friction. And then you have the model to use an extensible string and the weight of the string. Those are 3 things you can consider to make it more realistic. That's question 3. Question 3A. Question 3A. Final part of question 3A. Question 3B and 3C.